Something drifted into our solar system that is older than the sun, and it won't stop accelerating. Begin with a light that should not exist. This week, the European Space Agency announced that its Euclid Space Telescope had found 31 ancient quasars, blazing out of the era astronomers call cosmic dawn. According to NASA's Astronomy Picture of the Day and Science Daily, which both carried the finding on Wednesday, these objects date to when the universe was just 670 to 800 million years old. That is the deep past. The first galaxies had barely switched on. A quasar is not a star. It is the core of a young galaxy, powered by a supermassive black hole feeding on infalling gas, blazing brighter than the entire galaxy around it. To find 31 of them this early is to catch monsters that had almost no time to grow. And that is the problem. Objects this bright, this soon, strain every model we have for how fast the first black holes could gain mass. It deepens a puzzle researchers now call the impossible early universe. Euclid was not built to hunt quasars. Its wide-field survey is designed to map billions of galaxies across cosmic time, tracing the invisible scaffolding of dark matter and dark energy. These quasars were dredged up from an ocean of survey data, and as of this week, that count of 31 is only a first pass. More may surface as the analysis deepens. In the same news window, astronomers reported something at the opposite extreme. They named it M35, an ultra-faint dwarf galaxy orbiting our neighbor Andromeda, so dim that only 46 stars have been detected in it so far. 46. A galaxy you can nearly count by hand, sitting in the same sky as engines that outshine whole galaxies. The universe, it seems, keeps its brightest and its faintest secrets in the same drawer. But the most human story above us this week was not a distant black hole. It was a 50-year-old machine, running low on power, about to cross a line nothing built by hand has ever reached. On the 18th of November this year, Voyager 1 will do something no object made by human hands has ever done. It will become the first, one full light day from Earth. According to NASA Science and reporting from CNN, that is roughly 16 billion miles away, about 25.9 billion kilometers, though the exact figure keeps climbing by the second. Think about what one light day means. A radio command sent from Earth now takes 24 hours to reach the probe, and its reply takes another 24 to come home. Every conversation with Voyager 1 runs on a roughly 48-hour loop. Send, wait, listen. We are talking to a machine across a 2-day silence. It launched in September 1977 from Cape Canaveral, and it has flown without pause for about 49 years. In 2012, it slipped beyond the heliosphere, the sun's protective bubble, and crossed into interstellar space, the first craft ever to leave. Voyager 2 followed 6 years later. Nothing else has made that crossing. But this is a story about a machine that is running out of breath. The probe loses roughly 4 watts of power every year, and in April, engineers at JPL switched off its low-energy charged particles instrument to conserve what remains. As of this week, only 2 instruments are still awake, the plasma wave subsystem and the magnetometer. 2 working senses and a battery that dims a little more each year. And yet those 2 senses are enough to hear something extraordinary. Since 2017, the plasma wave system has been picking up a faint, persistent hum in the interstellar medium. The sound, in effect, of the plasma itself, letting Voyager measure the density of a region no other spacecraft has ever touched. JPL believes it can keep sending readings into the early 2030s before the power finally drops too low. 1 fading nuclear battery, 2 working instruments, a hum from the dark between the stars. But while our oldest emissary whispers its way outward, a newer machine had just screamed past a 2-headed rock at 11,000 miles an hour. Last Sunday evening, Japanese time, a spacecraft the size of a refrigerator threaded a needle in deep space. According to JAXA and reporting from Space.com, its Hayabusa 2 probe swept past a near-Earth asteroid named Torifune at 6:30 in the evening, Japan time, the very first encounter of its extended mission. This was not a gentle approach. Hayabusa 2 passed within about 800 meters of the rock, roughly 2,600 feet, while closing at a relative speed of around 5 kilometers per second. That is, 11,000 miles an hour, skimming a target the width of a small mountain from 100 million kilometers away from Earth. The margin for error was almost nothing. And the target itself is strange. Torifune is what astronomers call a snowman, or a two-headed asteroid. An elongated, two-lobed rock about 450 meters long, as if two boulders had been welded end to end. As the probe streaked past, its optical navigation camera captured the images, while a spectrometer, a thermal infrared imager, and a laser altimeter had begun watching from about an hour before closest approach, reading the asteroid's minerals, its heat, its exact shape. Why fly so close, so fast, at such risk? Because the real target is not the rock, it is the guidance. A flyby like this rehearses the high-precision navigation you would need to intercept an asteroid deliberately, the same skill that could one day let us nudge a dangerous one off a collision course with Earth. This is planetary defense, practiced on a harmless stand-in. Hayabusa 2 has done extraordinary things before. In 2020, it delivered actual samples from the asteroid Ryugu back to Earth. And now, it is on an extended tour of the solar system's smaller wanderers, proving its instruments still have sharp eyes. One nation had just rehearsed how to reach a tiny rock. On the other side of the world, another had gotten one better, closing in on a companion that has been shadowing Earth for longer than we knew it existed. Earth has a second, secret companion. It is called Kamo-Olewa, a Quasi-Moon, a tiny rock caught in a loose gravitational dance with our planet, orbiting the Sun in near lockstep with us. And this week, according to Space News and China's own state media, a spacecraft finally caught up with it. On Monday, the China National Space Administration announced that its TIANWEN-2 probe had reached Kamo-Olewa after a journey of roughly 400 days and 1 billion kilometers. The approach was patient, almost stealthy. TIANWEN-2 crept inward in stages, 30,000 kilometers out in early June, then 2,000, then finally settling to just 20 kilometers from the surface. From there, on the 2nd of July, it captured its first close-up image. That image did more than take a portrait. It confirmed that Kamo-Olewa is just over 20 meters wide, about 66 feet, matching what ground telescopes and even the James Webb Space Telescope had estimated from afar. But it also delivered a twist. For years, one leading theory held that this little rock was a chunk blasted off the moon by an ancient impact. The new data from the arrival undercuts that idea, and as of this week, the origin of Earth's Quasi-Moon is an open question again. TIANWEN-2 came prepared for anything. It carries 3 separate sampling techniques: hovering, touch and go, and an anchor and attach method built in for redundancy, so that if one fails, another can still grab a piece of the rock. The plan is to depart around April of 2027 and to drop a sample capsule back onto Earth late in November of that year. If it works, China will become the first nation ever to bring home a sample from a quasi-moon, and that returned dust could finally settle whether this companion is a fragment of our own moon or something stranger. But even a rock that shadows Earth is close to home. The next story exploded 1 billion light-years away, and it did something no dying star was ever supposed to do. A billion light-years away, a star died, and then it did something no dying star was supposed to do. It sang. According to a new study published in Nature and reported by Science Daily, astronomers watched a superluminous supernova, cataloged as SN 2024 AFAV, that refused to fade the way explosions are meant to. The blast was first spotted in December 2024. Normally, a supernova flares and then dims in a smooth, predictable decline. This one didn't. Instead, its light chirped, brightening and dimming in 4 distinct bumps, and each interval between them was shorter than the last, like a rising note. To catch it, the Las Cumbres Observatory's global network of 27 telescopes tracked the event for more than 200 days. So what was making a dead star pulse? The answer sits at the edge of Einstein's physics. Researchers attribute the chirp to lens-stirring precession, a wobble in spacetime itself, predicted by general relativity, produced when a spinning mass dragged space around with it. And at the center of that wobble, they found the culprit being born, a magnetar. The numbers are almost unreal. This newborn magnetar spins once every 4.2 milliseconds, hundreds of times a second, and carries a magnetic field roughly 300 trillion times stronger than Earth's. It is one of the most extreme objects the universe knows how to make, and astronomers watched it switch on. This is the first time anyone has ever directly caught a magnetar at the moment of its birth, and it settles an old argument. 16 years ago, a physicist at UC Berkeley proposed that magnetars are the hidden engines powering the brightest exploding stars in the cosmos. For 16 years, it was a theory. This week, the chirp made it real, and handed astronomers a brand new signature to hunt for in every future explosion. A dying star that sings the fingerprint of a monster. It is a strange week in the sky, but the strangest thing out there this week wasn't born in an explosion. It arrived from another star older than the Sun. It came in from the dark between the stars, and it is only the third of its kind we have ever seen. Its name is 3I/Atlas. And this week, a study in Nature turned it from a curiosity into one of the strangest objects ever measured. First, the facts. 3I/Atlas was discovered on the 1st of July last year by the NASA-funded Atlas Survey Telescope in Rio Hurtado, Chile. It is an interstellar object, a visitor from another star system entirely, the third ever confirmed after Oumuamua in 2017 and Borisov in 2019. As of this week, it is drifting through the constellation Gemini, slowly fading as it heads back out. Then, the Nature study opened it up. According to the paper and reporting from CNN, this comet's water is enriched with deuterium at more than 10 times the level found in any known comet, and its carbon isotopes run higher than anything in our own solar system. Those chemical fingerprints point to a staggering conclusion. 3I/Atlas may have formed around 12 billion years ago, nearly as old as the universe itself. A frozen splinter of some ancient planetary system, preserved since before the Sun existed. And then there is the part no one fully agrees on. As it swung near the Sun, at about 200 million kilometers, the object showed a measurable acceleration that gravity alone cannot explain. Most researchers say the cause is ordinary enough: collimated jets of gas and dust venting from a wobbling, rotating nucleus, localized outgassing, not a smooth melt. But Harvard's Avi Loeb has cataloged around 22 so-called anomalies and floated a far bolder idea that the push could be the technological signature of an internal engine. So the field ran the test. SETI pointed radio telescopes at it and heard no artificial signal. JWST and a very large telescope studied its light and found a comet, natural, if chemically alien, unlike anything born in our solar system. Not a spaceship. Something rarer, a chemical time capsule from a dead star's nursery, drifting through our sky by pure chance, older than the Sun, and still unexplained.